Sure is. Welcome, Corey.
Okay. Okay. Hey, good morning, everybody. Yeah, my name is Corey Gray. I have a lot of material to cover, so I'm going to just jump right into it. So let's go.
An achievement as historic as detecting space-time waves deserves special honor. And this year, we gave a special breakthrough prize in fundamental physics to the leaders and their teams who brought it to fruition.
Yeah, so when can you say that you've had Morgan Freeman talk about your work? I'm going to talk a little bit about the work that I do and the team that I work with. But yeah, it was super cool to have Morgan Freeman give us a shout out. So let me get to my title slide. I didn't know that I was supposed to start when after after the clapping or cheers, so that's why. Sorry for the little delay. So this is my title slide and the title of my talk. What we're looking at is a sunrise at where I work from a few years ago. This thing in the middle on the center bottom of the screen is a tube that's about 4 kilometers long, and I'm going to explain what all of this means throughout my talk. So just a few things first. What was I guess just I want to give some overview things that I wanted to share. So this is basically just my story about working, and I'm going to share about my educational path. I'm going to talk about my professional path. And then more recently, or into my career, I learned about how bringing your culture to your work is a good thing and helps. And because it's helped and saved me throughout college and throughout my professional career as well. And I think you'll see that throughout my talk, how I integrate my culture and just myself into my work. With that, what else should I say? I think that's it for this title slide. So let's just jump right into it. I'm looking at my talk, my time here. I usually give an hour-long talk, so I'm going to probably stop at about 9:45 to gauge if there's any questions. If there's not, I'm going to jam some more material in here because there's so much stuff I want to share with all of you. So, but I also want to take questions. So if there's questions at the end, I will end things off a little early and then leave some time for questions. So just giving you a rough idea of the plan here. So one of the things I'd love to share about is just my background and my family. I'm Blackfoot. I'm a member of the Siksika Nation. So this image here is showing you the rough traditional territory of the Blackfoot people in green. I would arguably say it's probably 2 or 3 times that. We're a plains tribe. We're in southern Alberta, Montana. That's where our reservation and reserves are. The 4 bands of Blackfoot are the Gaina, Piikani, Siksika, that's my tribe, and Amskapi Piikani. The 3 I list in red are the 3 reserves up here in Canada, and then the one in blue is the big reservation down here near Glacier National Park. Let's see. So a quick Blackfoot language lesson. This is a quick and easy one. How do you say hello in Blackfoot? So it's Okki. Some more language stuff. So recently I was given my new Blackfoot name. That was last summer. So in Blackfoot culture, you're usually given multiple names throughout your life. My first one was when I was a kid, and it was Agapo Suis, which means many weasel tails. It's a name that was given to me by my great-grandfather, Alphonse Slay, who I'm going to show. And it was honoring a relative on my grandfather's side, his name. So it's carrying on his name. I had that for most of my life up until last year when I was giving the new name Makuyuhsuku, which means wolf's path. And this is related to astronomy and the stars because the Milky Way, there's a Blackfoot story about what the Milky Way is, and it's with regards to a wolf's path in the sky. I could share about that later, or you could. I also talk about it online. I could share about that as well. This picture here is the Milky Way, and I'm showing it because this is a famous area in Washington State where I live, and I've actually hiked up this mountain right here. So I've hiked up it several times because it's a very fun and cool hike. Makoyosuku, so that's my Blackfoot name. Here, here's my family on my mom's side. So this is my mother, Sharon Yellowfly. This is my uncle, Sherman. And then here are my grandparents, Percy Yellowfly and Cecile Yellowfly. I'm their eldest grandchild. kid. So I'm their oldest grandkid. Um, let's see, I like these old photos. So there's going to be a few of those in my talk as well. Alphonse Slay, this is my grandma's dad. And this is at the Calgary Stampede. This is a photo my mom took back in the 60s. And I'm mainly showing it because of the teepee in the background. So this is a star teepee. I believe it's a red background with white circles on it. And I just like to show this because science and the sky and astronomy are such a big part of Blackfoot culture and Indigenous cultures in general. So it's in our stories, like I said, with my name, Wolf's Path. It's in our songs. It's in our designs on our teepees, and we're natural biologists, engineers, astronomers, scientists in general. So it's in our blood to be scientists as Indigenous people. I gave talks kind of all over a little bit, and I gave one in Calgary a few years ago. And around that time, I heard about medicine wheels. I didn't really know what medicine wheels were, but over the years, I've learned that Blackfoot people have constructed several medicine wheels in our territories. And so this article is talking about one of the older ones, one that's older than Stonehenge. And I had no idea about it. And it's right near our res, and I had no idea about it. So next time I went up to Alberta, I made a point to go and seek it out. And so this is, it was an adventure to get there because the path there was a bit rough to find. But here is my visit to the Iniskim Umapi, or it's buffalo calling stones. That's what this is in Blackfoot. That's what we call a medicine wheel. And so these were used for ceremony. It's a very powerful place when you're there. And they were also used to mark occasions in the sky, specifically solstices or equinox, because a lot of things happen as Plains people during the season. So when to harvest things, or where to follow the buffalo as well. So a lot of that we were able to use in our calendars by using the sky and these medicine wheels. So from this instrument of the Plains, I'm going to switch to an instrument in the desert of Washington State. And really quick, I'm going to switch my view. And I hope it doesn't change anything for you, because I want to be able to see my notes as I go. Did anything change? Does it still look okay? Does it still look full screen?
Everything looks great.
Okay, thank you. Okay, so I'm going to keep going. So yeah, from this instrument in the Plains, we're going to go to an instrument into the deserts of Washington State, the dry part of the state where I live. And so that's where it is. So my title slide showed a photo from right about here, looking this way when the sun rose. And this big L-shaped thing is the detector and the place that I work at. And I'm still waking up. I was actually on shift last night, so I got home at about 1 a.m. and I just woke up just a couple hours ago. So I'm still waking up. I have coffee right here. I'm pretty tired and I still have morning voice, so apologies for that. So this is the instrument. I'm going to share about what this is and how it works. But while we're here, we're going to take a quick little tour. We're going to take a quick drive down this arm here. This is the X arm. We're going to take a drive down this arm. It's about 2.5 miles. Those two arms are 2.5 miles. We're going to take a quick drive down one of them, the one on the right. Notice all the tumbleweeds. We had a big windstorm last night too. 1 kilometer. And here's 2 kilometers. There's a liquid nitrogen truck right there. Lots of tumbleweeds. Here comes 3 kilometers. And here's 4 kilometers. We have light in that tube right to the left. We flash light down that laser light through that tube. And I'm going to explain what all that means. But before that, we'll return to me. So yeah, I didn't grow up on the res. I didn't grow up in Washington State. I grew up in Southern California, just outside of LA. I don't know if you could tell who I am. Right here, this is me. In which grade? That's in grade 4. Rialto, California is where I grew up. And just a little bit about myself and how I got to where I'm at. So I grew up in Southern California, K through 12 in Southern California. And then I moved as far away as I could from Southern California, but not have to pay out-of-state tuition. So that was Humboldt State University. Now it's Cal Poly Humboldt, still getting used to that. And I received Bachelor of Science degrees in physics and also applied mathematics because there's so much math in physics. So I got 2 Bachelors of Science degrees. And during that time, I also did several internships. Internships are so important. They're ways to do work in the area that you're studying in. You could put them on your resume. When I applied for my current job, they looked at my resume and asked about my summer research programs, that work that I did, and then you get paid for it as well. So internships, especially for high schoolers and college students. I didn't know anything about them, so that's why I really like to stress the importance of them. I learned about a few of them through ACES. So organizations such as ACES and SACNAS, those things, they helped me find internships like that. So got my degrees, and then way back last century, that is when I graduated and started my job with Caltech, the California Institute of Technology. And I took my talents to here, Washington State, to work at this little outpost called LIGO, the LIGO Hanford Observatory. And back then we were just building this new scientific astronomy machine. And I was a builder. I worked with many other people, got to help build the machine. And then I became an operator. We're the people who worked on shifts 24/7. That's why I worked last night till midnight. And we drive the machines to collect data. And then what else? I've also been a supervisor, and I'm also a reluctant science communicator. Yeah, that's something I forgot to say at the beginning. You can't tell, but I'm a very shy person. It was very hard for me to give talks in the beginning. I was forced by my bosses to give talks, and I hated it. I almost peed my pants every time I did it. But I've learned over the years that it's super important to do these types of things, especially if you're Native, especially if you're Indigenous, because with me, a Blackfoot person in physics, you don't see other Blackfoot people in your classes. You don't see other Blackfoot or Indigenous people at your work. And because of that, when I learned that it's important to once you're out in the field, to get out there, let other Indigenous people, especially the kiddos, let Indigenous youth see what the possibilities are, what they can do, what they can study, and where they can work, and the adventures they can go on. So that's why I think it's now at a point where it's hard to shut me up when I give talks. So so that's a little bit about my path. That picture on the upper right is me and my bro. I'm the chubby one with the braces. You could tell I like to eat pizza back in the day. And then the photo on the bottom right is me up above our detector in one of the lab rooms. Here's a picture of me and my brother and my mom on our reserve on the Siksika Nation in southern Alberta. And here's my dad and I when I was a kid. My dad was a self-taught electrical engineer, and my mom and my dad were my first and biggest role models. This is the other operators that I worked with. This is back in 2016. This is the operator team. We all worked on shifts to run the detector. Oh, and my other role model, MacGyver. I wanted to be I'm dating myself. Well, you know how old I am now, but in high school, this was a show that came out, and I just loved that he was into physics. He liked to solve puzzles and problems without a gun or violence. And I wanted to be an Indigenous MacGyver. I'm still on that path to becoming that Blackfoot MacGyver. Okay, and so with my talks, I usually run long because I cram so much information into them. And because of that, one of the crimes that's happened, or that would happen with me, is that I would skip a lot of slides that were important ones. And one of them is just advice, especially for the younger audience members. This was something I hated that I skipped it. So I put it at the front of my talk. So this is elderly advice from somebody who's, I'm embarrassed about my age, but before I go into that, this photo, I'm hoping you might know what this is from. It's actually from a movie. It's called Interstellar, and there is actually a connection to that movie with where I work. I'll say it really quick. One of the founders of LIGO worked with the Nolan brothers to help them design Gargantuan, the CGI for Gargantuan and the wormhole in Interstellar. So I'll talk about him in a little bit, but let me give some advice. So internships, I've already kind of touched on this earlier, the importance of internships. They're so important. So if you're a high schooler or college student, make sure you apply to as many as you can. That's the thing. Every like February or the beginning of the year, I would start looking for internships and I apply to at least a dozen or more. And then I'd wait to see if I got how many I got accepted for, and then pick the best ones that I liked. Find your passion. There's been days when I've almost burnt out just because of just overworking, working crazy shifts, not taking time for my mind or to relax. And so I think finding your passion, which could be your work, but other passions as well. And I list a few here. Some of my favorites are travel, dancing, which whether it's powwow or salsa dancing, and hiking. I love hiking. And I also love kayaking now. So yeah. Fail. I fail so many times, but I think that is the best way to learn and improve things. I'm going to fail today because I'm not going to be able to cover everything I want because I'm a big blabbermouth and I talk too much, but I'm going to hopefully cover a lot of material during my time here. But fail is not a bad thing. It's actually one of the best things. Be ready for ideas. I always have ideas coming in through my head all the time. So I always make a point of noting them on my phone or writing them down when I can. And bring your whole self to your work. This is a huge thing, and it saved me so many times. And you'll see that in my talk. And here's just some action photos. This is me and one of my salsa friends. This is me taking my salsa friends to the powwow on the Yakima Nation a few years ago. Treaty Days, their Treaty Days, they just had their powwow over the weekend. And then here I am on a trail with one of my dogs, Gunner, when he had trouble on the trail. And then Veronica, I don't know if you're watching, but yeah, my connection to the American Indian College Fund is Veronica Hirsch. She gave a few presentations yesterday, and we've known each other for a while. And we met each other, kind of started our friendship from salsa dancing. So I thought I'd just throw a picture of her and I dancing. This is a decade old. This is from 2013. Okay, so a little bit about the science. So what do we do, or what does LIGO do? I'll talk about what LIGO is. So I'm hoping you know who this gentleman is here. Keep in mind that year, 1915. The general theory of relativity, that's when he unveiled it. That's when he changed physics. That's when he put physics on its head by coming up with a different way to explain how gravity works. My throat's going dry. So prior to Einstein, Sir Isaac Newton thought of gravity as a force between two objects. So you could have one object here and another object here, and they're attracted to each other by a gravitational force. So they could be orbiting, or they could be passing by and falling off the table. That works for most cases, but when you get to extreme cases, it fails. And so that's where Einstein had to solve that problem. And the way Einstein explained gravity is that objects, masses, bend the space around them. And so that's what gravity is. That's another way, that's a more thorough way of explaining what gravity is. The mass affects the space around it by bending space-time around it. I'm going to show a picture that kind of explains that a little better. So you have these two objects. You have a bigger object, a star, and then a smaller object, a planet. And we have this grid on the bottom that would normally be flat if there's nothing there. But now you can see these bends in the space-time. And those bends are the effects of the masses. The bigger the mass, the more dense the mass, the bigger the hole, or the bigger the warping in space that happens. And so if this is just a picture, you just see these two holes that they're making in space-time around them. But if you started moving them, if you had, in this case, this planet moving around the star, as that planet that moves around the star, it's going to be moving its hole, the bent space-time around it, and also causing little waves in space-time. And those little wiggles in space-time that are caused by masses moving around are called gravitational waves. And that is what we look for at my work. I'm not the best explaining things, so I love videos. So I'm going to show another video. And I guess I have to play it. Yeah, so this is from a movie from the last century. I'm hoping you know who this is. This is Neo, played by Keanu Reeves in The Matrix. And so he's kind of acting like a strong gravity object, such as a star or a neutron star or a black hole, and bending space, the matrix behind him, and then causing vibrations like that. Those vibrations are kind of what gravitational waves look like. And if there's ever a LIGO movie, I'd be totally fine if John Wick or Keanu Reeves played me in the movie for LIGO. Okay, how do we detect these guys? And so what do? We make the most sensitive ruler. And so this cartoon is kind of showing you what that L-shaped detector at the beginning is. And so the few things to note here, this is a laser, and then this is a chunk of glass that we call a beam splitter because it splits our light up from the laser, and then it hits these mirrors. So this circle is a mirror, and then this circle is a big mirror here. And then this square here is just a sensor, a light sensor to look at the light. And this comes from Ray Weiss. He's the person who invented this way back in 1972. And I always note this because he published a paper in April of 1972. It was basically 10 days right before I was born. So I have that connection to the project too. Okay, so let's watch a cartoon of how interferometers work. So LIGO, Laser Interferometer Gravitational Wave Observatory. That is where I work. So that's the name of my work, LIGO. And this is how LIGO works, using a big interferometer. So you have light from the laser hitting this beam splitter and getting split and going down these arms. These arms can be really small, but in our case, they're kilometers long. I said 4 kilometers earlier. So you have wave of light hitting that splitter, and then you have 2 twin waves traveling down each arm, hitting a mirror, and then those waves are going to come back and interfere with each other right here. And here they're canceling out just because of how we have the mirrors configured. But if you move the mirrors a little bit, change the distance the light travels in each arm, you'll see that you'll have positive and negative interference right here. So light and no light, light and no light. So tiny effects can be seen very easy on this light sensor here. That's how our machine works. And I'm going to go through it one more time just to kind of nail it down. So violent event out in space, billions of light years away. You have in this case, 2 black holes spinning around, getting ready to splash, explode into each other. They send a burst of gravitational waves. Then they form a bigger black hole, and then they go quiet in gravitational waves. But the gravitational waves leave that event, and they move at the speed of light throughout the universe. They pass through matter. They pass through other galaxies. They pass through other planets. They might even pass through other civilizations. And the wave that they make carries information from where they came from. So it has information embedded in the wave. And that's what we look for. We're being showered by them right now. So there's black holes gobbling up other black holes. There's neutron stars getting eaten by black holes. Those violent events send these signals from where they come from, and they're passing through us right now. But luckily they happen very far away, and they get small by the time they get to Earth, and they pass right through the Earth. And for the most part, they've not been recorded up until recently. And I'll share that in a little bit. So here's our detector. Let's take a look inside of one of the buildings. So let's say one of the end stations here, just to look at one of the mirrors. So here's in that cartoon, the 2 circles that we saw at the end of the arms. This is what one of them looks like. We have it built so that this mirror on the bottom, about 80 pounds, is floating. It's basically suspended on several pendulums, and it's floating and waiting for just a violent event to move it just a little bit. And we have those suspended throughout our machine. Okay, now let's go into the corner station right here. Oh gosh, it's 9:30. I have 30 minutes. Okay, here's our corner station. This big building here, we're going to take a trip inside that. And our laser is way over here. It hits the beam splitter in this chamber, and then half of the light gets split and goes down this arm, we call the Y arm. This is where I took the photo of that sunrise. And then the other half goes right through the splitter and goes this way, 4 kilometers. The light travels down the arms 4 kilometers. It actually travels several times because it gets bounced back and forth a few times. Then the light returns back to the beam splitter, and then we look at it out this arm right here. We have sensors down here. Here's a person walking around, just for scale. I took this photo about 10, 15 years ago. Any other things worth pointing out? Okay, yeah, let's go into this chamber right here, because in this picture, the door is removed. That's what that white cloth cover is. And just so you can get an idea of what it looks like inside of this detector, this is actually me. This is me connecting cables to a light sensor right here. These light sensors take light and convert the light into a voltage. Once you have it as a voltage, we can do different things with it. We could analyze, we could turn it into data. We could look at it at a computer, do analysis on it. We could plug it into a speaker. We could listen to our light with a speaker because of these sensors. What does the light look like? So here is a video of what the light looks like when I was on shift a few years ago. And I was just taking a video. This is looping every few seconds. And what you're seeing is 8 seconds on the horizontal axis, and the vertical axis is just amplitude, how big it is. If I could plug this into a speaker, it would sound like this. It would sound like white noise, like a white noise machine, or like static on a radio if you're not looking at if you're at a frequency that's not a radio station. So just static. There's nothing going on with our machine. So our machine's an L, and our machine's running, collecting data. Nothing's moving our mirrors, and this is what it looks like most of the time. So remember this red squiggly line, no kind of shape to it at all, just random. There's nothing moving our mirrors at all. Remember this. For time, I'm going to skip through a couple slides now. I usually kind of talk about things that I build, and I'll just skip through them really quick. So this is me. I built this thing right here called a beam diverter, and I actually built the table that all of this is connected to. But I just for time, I'm going to skip through this. But learning how to build a lot of this stuff has helped me have the confidence to build things on my own. My garage door broke just a few days ago, so instead of paying someone $500 to work on it, I looked up how to fix it and bought springs for $200 and did it myself. And I wouldn't have had the confidence to do that without learning about procedures, how to read drawings such as this, et cetera, et cetera. And it also gave me the confidence to do something even more fun. And that is, let me skip through this. That was to build a kayak. So this was my project during the pandemic summer of 2020. And something I wanted to do was build a kayak. First off, kayaks are indigenous engineering, indigenous tech. They've been around for thousands of years from the indigenous people of Greenland, Canada, and Alaska. And I got to build one. I saw a wooden kayak once on a hike along a lake, and I thought they must cost thousands of dollars and be hard to buy or whatever. But then I learned you could build them. So once I found out about that, I was scared at first, but eventually I just did it. And here's some pictures of some of the drawings, and I had a procedure and a video to follow. And then I ordered it, and here are the parts. And then that was May. And then by September, I had a working ocean or sea vessel to take onto lakes. And so I've been kayaking kind of nonstop ever since. And then here's just some pictures of me through the years. And then when I had darker hair, less white hairs. So here, the top two corners are me giving talks on the Yakima Res. You could tell this is a long time ago because I'm using an overhead projector. I don't know if some folks would know what this is actually, but before PowerPoint and stuff like this, this is how you gave talks. Here I am driving a forklift. Here I am working an optical level. And here I am working with an engineer in Colorado, getting ready to build a new LIGO detector. Here I am at MIT, working on finishing up building a table for us. And then here I am with that engineering group in Boulder, Colorado. Yeah, so a lot of what I've talked about is my first 17 years of the project and my schooling before that. For the most part, my job was a job up until recently. It was just building things. It was working behind a computer, not knowing what the big picture was. Okay, so I got 10. Okay, looking at my time. I was a little afraid to talk about the dumb questions, just because it's intimidating to work with such smart people. And that's a stupid thing to say or to think. But a few years ago, I had a roommate who was a grad student who worked with us, and he became my friend. And we went on a hike, and this is a hike that we did. This is the Pacific Crest Trail. I didn't hike the whole 2,600 miles. This was just a section of it. Here's Mount Adams, and here is Old Snowy right here. And I remember as we were hiking to the top of this, we camped right to the right here. We had a camp right here. As we were hiking, because this is my friend, I was able to ask him questions. So it's September, this is 2011. At that point, no detections made. I'd been working for over a decade with this project, no detections made. It started in 1972 from the idea from Ray, and no detections made. And so I asked my friend, because at this point we were building the new detector, and I asked him, when do you think we're going to make our first detection? And without skipping a step on the trail, he told me the statistics, how soon we would make detections, how many we would make per year, per week, what we would see. And I think that night when I was sitting at the campfire looking up at Old Snowy with a clear sky above and the Milky Way as well, that's when I thought about what it would be like when that first detection happened. Would I even be with the project, or would it be decades later? I didn't know it at the time, but 4 light years away, a signal was inbound to the Earth and on a collision course with us. Another movie reference. I'm sure we all know what this is. So 4 years after that hike, September 14th, 2015, this is when we made our first detection. This is the very first detection of gravitational waves. What we discovered were 2 large black holes. So let's see. Let's take a basketball. Let's make it as big as Seattle. And then we'll take another one and we'll make it as big as Portland. And then we're going to basically throw in about 30 suns into each of these basketballs that are big as these 2 cities. And then we're going to spin them around, have them in orbit with each other in a dance, and then getting faster, getting closer and faster and faster and faster, moving super fast. They're moving at almost the speed of light. So strong gravity objects moving very fast, bending, warping space around them, and causing huge waves and gravitational waves. The biggest wave happens right when they crash into each other. This happened 1.3 billion years ago, or 1.3 billion light years away. So very far away, a long time ago, this event happened. And then the signal came from that. And then as it traveled over 1 billion years, as it took that time, all this history happened on Earth. Dinosaurs became alive, they went extinct, humanity started, Einstein was born, came up with the idea of gravity, and then ideas of building LIGO occurred. And then we went online about at the beginning of September of 2015. And a couple weeks later, we caught it. We caught our first detection. I was on shift. It was kind of a similar shift. So I worked 4 p.m. to midnight, and then I went home and handed it off to the next operator who worked the graveyard from midnight to 8 a.m. 2:50 in the morning is when this detection passed right through the Earth and was recorded for the first time by LIGO. We have 2 detectors. There's one in Louisiana and there's one in Washington State. I work in Washington State. This is what Louisiana saw at 4:50 in the morning. And then 7 milliseconds later, this is what we saw in Washington State. Remember the red squiggly line that sounded like, compare that to this. And let's put this on top of each other. Take the data from both of our machines, and this is how well they line up. This is what we saw. This is the last few moments right before the black holes crashed into each other and formed a larger black hole. This is our first detection. It's only about 1/4 of a second long. So it was a very quick part because it's only the loud part, the explosion, that's the part that we can see. That was loud enough for us to record. Gravitational waves aren't sound, but you can, wait, before we go, I want to share a little bit. So this is when I saw this for the first time. This is when all of our lives changed. So basically that night when I got home and went to bed that night, so by the time my head hit the pillow and my eyes were closing, probably around 3 in the morning, that's when the signal passed right through me. And then it passed right through all of you. And then it passed right through the earth. And then it continued on its way at the speed of light. But it was recorded. And this is what it looks like. This is what the recording looks like, the data. And like I said, it's not the gravitational waves aren't sound, but the data can be put into a speaker. And this is what it sounds like. I'm hoping you could hear that. Okay. That's the raw data. That's the full data. I'll play it again. And it's looping. It's just the whoop, but we're looping it here. To hear it a little bit better, we're going to shift it in frequency so it's a little easier for our ears. And then that's a text tone that I have on my phone. Okay, so what does this look like? We could take the data that, that's what we just saw and put it into a supercomputer and give you a visualization of what it looks like. And so here it is here. Yeah. Using our data, this is what it looks like. These are the two black holes. They've been dancing for millions of years. This is the last moments before they crash into each other and send out an explosion of gravitational waves. The pink lines in the background are the big waves. That's the big wave we saw, that pink line right there. Okay, so just to nail it down, what happened? So history made on September 15, 2015. This is one of the biggest discoveries that's happened in the last century. There's been a few others, but this is one of the big ones. It was the first direct detection of gravitational waves. This is the first time that binary or pairs of black holes have been observed. And it's the birth of a new field of astronomy, gravitational wave astronomy. And it happened almost to the month 100 years after Einstein predicted them as well. So you couldn't write a better script. That happened in September 2015. We couldn't say anything until February the next year because we had to confirm the signal. We had to work on writing a paper to share it. And then what else? Oh, then we had to get ready to make our announcement as well. And so this is the press conference for it. If you look it up, you can look this up on YouTube. It's an amazing video. I watch it at least once or twice a year. Ray Weiss is right here. And then Kip Thorne, he's the person who worked with the Nolan brothers in Interstellar. These are the two people who came up with the idea of this whole project in the early 70s. And then we were, when we announced, it was so cool just to see the reaction, public's reaction in pop culture. So we were on The Late Show, we were on Saturday Night Live. Von Miller, who plays for the Broncos, talked about crashing into people like these black holes crashed into each other. And then our data is right on, I don't watch this show, so I can't remember his name. Sorry. But Big Bang Theory, our data, it was so cool to see our data on Big Bang Theory. So yeah, another side project or another side story I'd love to share is probably the one that I'm most proud of. So this was a big discovery. And right before we announced, we talked about how we were going to share this in as many languages as possible. I was in one of those meetings when talking about the press release and translating it into a lot of languages. I didn't bring it up in the meeting, but I did send an email later to one of my colleagues asking if it'd be okay if we could have this press release that would receive a lot of attention translated into Blackfoot, an indigenous language. And my colleagues were totally fine with it. And so, yeah, so that was something that I was able to bring my mother in to help with. And so here are some images of the translation that was printed on, I think it was Indian Country Today, where they published the translation with English and Blackfoot. And then here's another article about it right here. And then my mom was in Native Peoples as well. So this is on the Yakima Res at their museum. I got the magazine there. This is a tie that actually has the data for us as well. Here's my tribe's paper here. And here my mom is at with me at a conference, the SACNAS conference later that year. And she bought a t-shirt from the conference, and she sat with my colleagues at the banquet table, and she was so cute because she had all my colleagues autograph her shirt. And after that, not much happened as far as attention to my mom's amazing work. That was 2016. But then in 2019, I received a call from NPR's Nell Greenfield Boyce, and I listen to her all the time. I listen to NPR when I go to work. She called and said that she wanted to do a story on my mom's work. And so let's let me just play like just a few seconds.
Tomorrow, scientists will officially restart their search for gravitational waves after spending over a year improving the massive machines used to detect them. NPR's Nell Greenfield Boyce reports on how this cutting-edge field of science is connected to a Native American language, Blackfoot.
Gravitational waves were predicted by Albert Einstein more.
So what's cool about this is millions of people heard this story. They got to hear the word Blackfoot. They got to hear Blackfoot words. They got to hear my mom's voice. They got to hear my voice, but they got to hear my mom's story and how she's a survivor of boarding schools and how she was able to bring her language to astrophysics. And I think it's just a huge thing. She's had several articles written about the work she's done. This is one from 2021. And I love this one in particular because the reporter commissioned a Blackfeet artist to do art. So this is ledger art, in case you're familiar. But what I love about it is that they're in the ledger art, they're using the artist, Taryn Last Gun. This is his interpretation of black holes and gravitational waves. I have it actually on my wall right here, his backup art from this article. And then, yeah, my mom and I have given a few talks over the years. So this is our first one at the University of Lethbridge. Before I get into that, Aaron, I don't know about questions and stuff. I was going to check with you right around now. So like I could talk about one more detection, or I could end things within about 5 minutes. What do you think? Or should I go until the end of the hour, or should I stop in about 5 minutes? I can't see chats or anything, so I don't know if I don't hear anything. I hope I'm still online. I hope I'm not just talking to myself.
You are still online. We're not seeing any questions specifically, just a lot of comments. So yeah, feel free to continue.
I'm going to just take up most of my time then. So I have 12 more minutes. Okay, 11 minutes. So yeah, so this is me. This is me being the opening band. My mom is the headliner. This is at University of Lethbridge, which is in Blackfoot territory in southern Alberta. So a lot of the audience members here are Blackfoot. They're Blackfoot speakers because this was an Indigenous language conference. And in the agenda, that there is a session about astronomy, and I'm sure they were wondering why we were there, but we were there because of my mom's amazing work. And in that audience, there was people from our tribe, and the coolest thing was afterwards, just there was a long line of people from Siksika who were there with the Siksika Board of Ed, and who knew my mom, were friends with her and grew up with her, and they were hugging her, and it was just such a cool thing. It was such a cool thing to see it. It was just really cool. This slide always gets me though. Oh, my uncle's way back in the back. So that's Sherman. And then this is my mom right there. This is my mom over the X-arm. And I actually recorded my mom on YouTube saying the words to the first press release. So you can look that up on YouTube. Why is this important? I mean, a lot of us here, we know the story. So this is important because my mom, as with a lot of our family, were forced and stolen from their families, from their parents to be forced to go to boarding schools. This was federal policy of both Canada and the United States. So this is where my mom was stolen and forced to go to school. So my mom, the girls lived on this top floor here. The boys lived on the left side here. The experience for my tribe was unique in that we had 2 boarding schools. on either end of the reserve. So my mom was in the Catholic one here. The Protestants had the other boarding school. So this is Crowfoot. Before my mom was taken away at the age of 5, this was her life. So this is where she lived. This is where she was surrounded by family. Blackfoot was her first language. And all of that was taken away from her when she was 5, as it was taken away from all Indigenous people, our families. Here's a picture of their house. Here's my mom when she was really young, and my grandma, my grandparents. Here's my mom and Sherman and their dog Spike. This is a photo of I think my mom took the photo of here. And then here is a picture of my mom as well. Dang, I have 9 minutes. Okay, I'll see what I can do. This is a picture of my mom. When I look at this photo, I think of space-time. I think of relativity. If you remember the movie Interstellar, if you get close to the closer you get to a black hole, the slower time gets, the closer you get to it. So if you get right near the event horizon, time will basically stand still from people looking at you. For you here, it's still moving. But when I think of that, I think of these kids, just what it was like to be in these boarding schools and how time must have slowed down so much because of the pain and the loneliness and just being away from family. And that's just something I think about when I look at this photo. Here's my mom. My mom received a degree in anthropology. And so this is her going back to the site of the boarding school. And with her anthropology or archaeology hat on, she talked about what we were seeing there and kind of shared some stories. I don't ask her about it because it's trauma that she has. And then I'd like to also just share some of the positive things. So just how Indigenous languages are used in different ways. So the Navajo code talkers during World War II. Here are some Blackfoot sportscasters giving play-by-play for a hockey game. Star Wars was dubbed in Navajo. And then if you've seen the first Wonder Woman movie, I mean, I love that when I was in the theater, packed theater, I heard Blackfoot in that movie. And that's from Eugene Braverock. Here are some of the Blackfoot words and the English words, the Blackfoot words for English words. A lot of them we already have in Blackfoot. So here are examples right here. These are the categories my mom had for the types of words she used to make the translations. And then these ones take other words together, putting words together. That's why eggplant is there. So the word for egg and plant are put together to make the word eggplant. And so that's how she did words like black hole and binary black hole. And then other words that were harder to come up with, I explained to my mom what the scientific word is, and then she thought about it and talked with other family members and came up with new Blackfoot phrases to give us new Blackfoot words for these scientific terms. And then there's ones that are just, there's so much in the word or the phrase that she had to take a literary license. So for general theory of relativity, to make a Blackfoot word for that, she said would have taken a page. So she took literary license and came up with the Blackfoot word Bisatsin Siman, which means beautiful plantings, because general relativity planted so many other things in science. It touched so many other things. Here's my mom.
Okay, or hello. I am Sharon Yellowfly, a member of the Siksika Nation, and the following neologisms, or Manipursin, I've created to communicate about physics in the Blackfoot language. Physics. Esatsimia, ma istutsi, natusi, ki kakatusi. Observing where they come from.
Okay, man, I'm at the 5-minute warning. Shoot. Okay, I told you I'd fail, and I'm trying to think about what would be the best things to share in 5 minutes. This is my second favorite detection, and I'll share a couple of things about it because it's not black holes, it's stars, and this is one that I was in the chair for. And I'm just going to talk about it because I don't have time. This was in 2017. My second favorite detection. Why did I love it? Is because right before I was on shift for this detection, I went up to Canada because my cousin and I I'm going to skip through. My cousin and I'm skipping that. We came up with the idea of having ways of outreach work. So we wanted to have a gravitational wave grass dance special. And so that's what we did at our powwow. Before the powwow, I attended a Sundance, I think on the Gaina Reserve. And I've not attended many, but one thing I did was I got my face painted and by an elder. And when you do that, you think about positive things. And so one thing I thought about is just wanting to be better at my work. That's one thing. That's one positive thing. And then we had this a couple days later. We had the special. Here are all the grass dancers. Here they are here. My grandma told me, because I'm a grass dancer as well as a northern style singer, old style singer. My grandma says that the steps of dancers are like prayers. So those are two things that happen related to my work. And I think that those things had an effect on my work, because when I drove back home, a couple days later, I was in the control room for this huge detection, which was basically two neutron stars crashing into each other. Last night, a few hours ago, I was sitting right here, and I was sitting here back in 2017 when we saw two neutron stars crash into each other. And I believe that the power from the Sundance and then all those grass dancers had an effect on that. Okay, so I'm going to skip through. I would tell you more about this huge discovery, but that I don't have time. So I'm just going to skip to some of the other points that I wanted to share. Well, this one's a cool one. This is us seeing the stars crash into each other, and then a satellite seeing gamma rays. That's us. And a satellite seeing gamma rays. It was seen optically as well, but I don't have time. The other thing I need to always talk about is the Nobel Prize in Physics, because Ray and Barry and Kip Thorne all received the Nobel Prize in 2017. I knew that when the founders ever got the Nobel Prize, I would go to Stockholm. I would pay my own way, take vacation time, and just be there. And of course, I've gotten pictures with all of them. Oh, this is a cool thing. Kip Thorne wrote this email to me, and I can now say that I've moved a Nobel laureate to tears just from an article I wrote. Okay, so that's a Nobel Prize. That's I have a tattoo. I didn't show it, sorry. I'm skipping through. This is Stockholm. This is us tailgating outside. This is me and my siblings. Those are chocolate Nobel medals. I share all these pictures because when do you get to see Blackfoot people or indigenous people on the streets of Stockholm during a Nobel ceremony, or hiking on a trail with a corgi in their backpack, or dancing with other natives at a salsa club, or powwow dancing? I always like to share that stuff. And I got a minute and a half. This is me and my friend. This is the next project we're working on. This is a comic that we're hoping that comes out this year, and it's inspired by my mom's work. And I'm gonna skip all the way. Shoot, how do I skip through? Okay, I have to just go through like one at a time. I want to end with my mom, and I have 1 minute. Crap, get over here. Okay, sorry, I'm cutting it short. So this is my mom and just some clips.
Mustis glaigo, ita pohku, quis Udespumuk Mixisk National Science Foundation, NSF, ki Mixisk Caltech, ki MIT, and
this is her finishing the video.
Niskskat Simya. Son of a biscuit.
She said biscuit. She didn't say a bad word. So this is after a talk we gave at McGill University in Montreal. And I just think of that little Blackfoot girl and how her words would be connected to Albert Einstein and astrophysics. And so here's my mom. And I'm going to end right here with 10 seconds to spare. So thank you so much. I'm sorry I had to skip a lot, but thank you so much for the invite and at least giving me your time during this talk.